Okay, everyone, so I'm going to go through the exam 3 review that I sent out in an announcement. I apologize that I was not able to do this live, but hopefully this will work out okay. So question number 1, suppose the city of Harriman has 58,000 registered voters. There are 2 candidates for city council in the upcoming election, Gardner and Orgill. The day before the election, a telephone poll of 250 randomly selected registered voters was conducted. 135 said they'd vote for Gardner, 97 said they'd vote for Orgill, and 18 were undecided. So question part I, or the first question is, give the sample statistic for the proportion of voters surveyed who said they'd vote for Gardner. So we're going to go up here. If they have voted for Gardner, then I'm going to pull that information from the 135. So 135 is the raw number of people that want to vote for Gardner, but you want to, of course, make this into a fraction. You want the statistic or out of how many possible voters. So we don't want to go to 58,000 because that's not the number that 135 was drawn from. Instead, it was drawn from the 250 people or registered voters that were randomly selected. So we're going to take 135 over 250. Now, this is where on the test you want to be careful and make sure you're following directions. It does ask you to write this as a simplified fraction. So if you have a calculator that will simplify your fraction, you're going to put 135 over 250. And that's going to give me 27 over 50. If you didn't have a fraction calculator, you would just, of course, divide by whatever the common factor is. So you could divide them both by 5. And so the sample statistic is 25 over 50. Sometimes we put statistics as fractions, sometimes percent, sometimes decimal. Of course, if you wanted a decimal, you take 27 divided by 50 and write that as a decimal. And if you wanted it as a percent, of course, you'd move it 2 places after changing it to a decimal. So part 2, how many of the 58,000 registered voters does the sample statistic suggest will vote for Gardner? And so because I left this as a fraction, I'm going to go ahead and set it up as a proportion. So going back to what we learned about in module 1, you can set up a proportion. If basically 27 out of every 50 people plan on voting for Gardner, you want to know how many out of 58,000 voters. So we can do this by cross multiplying. I'm going to take 27 multiplied by 58,000. That's going to be equal to 50 times by the x. So I'm taking my calculator, 27 times 58,000. That's 1,566,000. And we're going to divide that by 50, of course, to solve for my numerator. So if I divide that by 50, I'm expecting 31,320 voters. Okay, let's move on to question 2. Question 2, you are given a table, a frequency table to be more precise. And for the first part, it's asking you for the mean, or in other words, the average, what we typically think of as average, cups per day for the class. Because this is given to me as a table, I have to interpret what this means. So basically, one person drinks no cups of water per day. So I could say, that there would be someone who said 0 cups. And basically 3 people drink 1 cup per day. So if I wrote that out as far as cups of water per day, I would have 3 ones. And I would have 5 2s, etc. Right? And like if I was asking for the median, you don't want to necessarily have to write these all out and find the middle number. So we will do that in just a little bit, finding the median. But to find the average, we want to basically multiply to get the sum of each column and then add them together. And then we're going to divide by the, it's a little symbol for sum, the sum or the frequency. So I'm going to take 0 times by 1 plus 1 times by 3 plus 2 times by 5 plus 3 times by 4 plus 4 times by 8 plus 5 times by 3 plus 6 times by 3, etc. 7 times by 2. So it's a long one. 8 times by 0. By the way, you wouldn't even have to do that if you're going to use the 0, because it will, of course, equal 0. And when you add 0 to anything, you get the same thing. And then I'm going to add up my frequency, 1 plus 3 plus 5 plus 4 plus 8 plus 3 plus 3 plus 2 plus 0 plus 1. And I get 30 people. So there were 30 people in the class. And for the sake of time, I will put the answer in the key, but that's how you would find it. To find the 5-number summary. So a few of you guys struggled a little bit to find Q1 and Q3 on your last project about the magnets and paint. So I do want to definitely hit how to find Q1 and Q3 mathematically on a test. So let's talk about, first of all, the first number, which is your minimum. And that would be the minimum number that appears. In this case, it would be 0. So somebody had 0 cups of water per day. And then let's just jump over to the max, which would be 9. Okay, so someone mentioned that they drink 9 cups per day. So that's going to be your max. Just write that. Now, to find Q1 and Q3 and also the median. So Q1, think about Q as in quarter. So the first quarter would be 0.25. If you think of a quarter, it's 25 cents. If you think of the third quarter or 3 quarters, it's 75 cents. And the middle of those two, or the median, is half. So what I'm going to do is take 0.25 times by the frequency. Okay. And I'm going to do that for each of the Q1, the median, and Q3, or how many people did I ask? Okay, which would be 30. So for Q1, I'm going to take 0.25 and I'm going to multiply it by 30. So 0.25 and I times it by 30, I'm going to get 7.5. Now, this is where some of you guys made a mistake. So 7.5, anytime you have a decimal, that means even if it was a 0.1, whether it's 0.5 or 0.1 or 0.01, you're going to round it to the next value. Okay, so don't think about typical rounding rules. Instead, just always round to the next value. So I'm going to round this to 8, or look for the 8th value in my data set. Okay, now to find the 8th value, you're going to think about adding up the frequencies along the bottom of the table. So the first value is a 0. The 4th value, okay, 1 plus the 3, or the 4th value is a 1. So basically the 2nd through the 4th values are 1s. And then the 5th through the, if I add my 5 to the 4th value, the 5th through the 9th values are all 2s. So the 8th value has got to be a 2. Okay, let's go through that again, but with the median, and then we'll do it again with the Q3. So median, think 0.5. You're going to times that by, there were 30 people asked, so that's 15. Now, if it's whole, that doesn't mean we use the 15th value. Okay, so if it's whole, what I end up doing is taking the 15th plus the next value, and then we're averaging it. Okay, so I'm going to take the 15th and the 16th value. So we've got 4 more here. So this is the 10th up until the 13th value. And then 8 more beyond the 13th is 21st value. Okay, so that means the 15th value, or basically the 14th through the 21st value, are all 4s. So if the 15th and the 16th value were different, I would add them up and divide by 2. You can still do that if they're the same, but you'll see here it is kind of silly to do that. What's in between a 4 and a 4? Well, a 4. Okay, so the median is going to be a 4. Now on to Q3. Q3, think of that 75 cents for the third quarter, or 3 quarters. I'm going to take 0.75 times by 30. That gives me 22.5. Again, because this is a decimal, I'm going to go to the next value. Okay, so that's my thought bubble there. So I'm going to look for the 23rd data point. Okay, so I'm going to just keep going here, looking at, I'm already to the 21st, add 3 more. That's going to take me everything up until the 24th. So the 22nd through the 24th values are 5s. So the 23rd value is going to be a 5. Anyway, I hope that helps with determining Q1 and Q3 as well as the median. Okay, let's jump to question number 3. So the exam scores for a test that include both math and physics is shown below. If Anita received 82% on the math portion, what percent of students scored higher on the math portion than she did? Okay, so let's look at math portion. So there's my clue, meaning I'm going to look in this middle box plot for mathematics. Let's go up until there's an 82. And so Anita is sitting at the top of a box. And so what this question is doing is asking you, can you interpret what box plots mean? And so when we drew box plots on our last project, we drew them horizontally, but you certainly can draw them vertically as well. So since Anita is closer to the end than she is the low end, she's closer to the higher end. What we want to know is this is basically the lowest or the minimum. Okay, Q1, Q2, Q3, and then the maximum. There's your 5-number summary. It's just all along each box or each part of the box plot, I should say. So Anita's sitting at Q3, which means, remember, 3 quarters is 75%. So 75% scored lower than her. Got to be careful on this one because it actually asked how many scored higher than her. And so we want to think about, well, if 75% scored lower, to figure out how many scored higher, I'm going to take 100% minus that 75%, or in other words, 25% of the students scored better than she did on the exam. Okay, And looking at LaShonda, if LaShonda scored a 35% on physics, so now I'm going to look at the physics box plot, and 35%, so looking along the left-hand vertical axis, 35% is down at the bottom of the box. Okay, so that would be Q1, or 35% for physics. So let's look at what percent of students scored lower than. So we want to know what percent are down here. And because it's Q1, it would be 25%. All right, moving on to question 4. We're going to talk about probability here. Let me just mention on this one, even though I have this on the practice exam or review, I don't usually ask these questions on an exam unless I give you a picture, similar to when you did the exercises. Because I don't assume that a lot of you guys know face cards as well as maybe I do, or someone else who plays cards does. So this is an example of finding probability, but again, we would give you probably something more like the marbles, pulling out a green marble versus a red marble, or something a little more specific where you are given numbers. So standard deck, let's just review real quick or help you understand. A standard deck has 52 cards. There are 4 suits. And so there are 13 cards in each suit. So everything from a 2, 3, 4, 5, 6, 7, 8, 9, 10, and then Jack, Kings, Queen. And we generally don't include jokers, but find the probability of drawing a king and an ace. Okay, so this one's kind of a silly question. If I draw one card, it's got to be a king and an ace at the same time. So you've got 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. So, oh, an ace. Okay, there's my 13 types of cards. So can I draw a king and an ace at the same time? No. So, yeah, a silly question. So there's a probability of 0 for one single card. What's the probability of drawing a spade and a face card? So these are considered faces, a jack, a queen, and a king. If you had the cards in front of you, you would literally see faces on them, like people. And so those are considered faces. So spade is a suit. And so there would be a jack, a queen, a king, that all are spades. So there's 3 face cards out of the deck of 52. So you would say, in order for there to be both spade and face, okay, I would have 3 of those out of the 52 cards. Find the probability of drawing a king or an ace. And so this is where it would be helpful. I'm not going to pull up. If you have the picture in front of you, that might be helpful. It would take me too long to draw it all out. But so that goes back to that first question. The first question was an and, but this one I'm asking an or. And so it's possible to draw a king or an ace. There are 4 kings and there are 4 aces in the deck. And so the probability of drawing one or the other, we would add those 2 together, or 8 out of 52. And we could reduce that. We should usually reduce our probabilities. So I'm going to divide those both by 2. That's going to be 4 out of 26, or basically divide by 2 again, which would be 2 out of 13. Part D, find the probability of drawing a spade or a face card. So the spade is a suit. It's kind of looks like an upside down heart with a little tail, or a face card. And so this is where there's some overlap. If we think about it like a Venn diagram, there are 13 spade cards. Upside down heart with a little tail. And there are some face cards. There are 3 face cards in each suit, so there are basically 12 faces. But we want to know how many are between those, okay? So we can't just add the 13 and the 12 faces, because there are a few of those cards that are both. And so we have to subtract out what are both. So there would be a jack of spades, and there would be a queen of spades, and there would be a king of spades that would be both a face card, and I should probably draw those in black, but you get the idea. There are 3 cards that are both of those. And so to figure out an or statement, we would say that we have 13 out of 52 for the, basically what we would write mathematically is the probability of spade, plus the probability of a face card would be 12 out of 52, but we're going to subtract the probability of being both a spade and a fade, and a face, excuse me. So we're going to subtract out the 3 that are both. So 13 plus 12 is 25, minus 3 is going to be equal to 22 out of 52. Notice I don't reduce until the end. I like that to keep that denominator 52, and that would be 11 out of 26. Okay, question 5. Answer the following probability questions. If we roll 2 die, one at a time, are the rolls dependent or independent? So this is kind of an understanding vocabulary question. What does independent versus dependent mean? So I like to think about independent, like one doesn't affect the other. Dependent means one does have an impact on the other. Like if I take a card out of the deck, now I have 51 less cards to draw from. So my probability of drawing the same card again goes way, it changes, right? So in this case, because it's dice, it would be independent. And so you would explain that as, I'm not going to take the time to do that, put it on the key, but basically independent because one doesn't impact the other. If we roll the 2 die as described, find the probability of getting a sum. So I like to think about how can I get a sum of 12. So on a dice, I could have a 6 on one of them and a 6 on the other, right? And that would give me a sum of 12. So you could put that as 6, 6. Okay. But we also have, do we have any other ways of getting a 12? Could you get 4 on one and 8 on the other? Well, not if you understand a die, which only has 6 sides, right? And so the max you can have on a side would be 6. And so there's only, you must get a 6 on one and a 6 on the other. So the probability of getting a 6 is 1 in 6. And we're going to multiply that because it's independent by the chance of getting another 6, which is 1 in 6. And so the probability of getting a sum of 12 would be 1 in only every 36 rolls. Again, on average, in the law of big numbers. Okay. If we roll the 2 die as described above, find the probability of getting 2 even numbers. So we want to find the probability of getting an even number on the first die, and then the probability of getting another even number. So the probability of getting an even number, if we think about even, it's 2, 4, 6 on a dice. So that's 3 in 6, and then another 3 in 6. We could reduce those before we multiply. It's 1/2 times by 1/2, which would be 1 in 4. So the chance of getting 2 even numbers is 1 in 4. All right. Question number 6. Suppose an AC manufacturing company estimates 3% of their AC units will fail after the original warranty period, but within 2 years of purchase. The average replacement cost is $2,000. I think that's actually pretty low, but maybe that's the repair cost. They offer customers a 2-year extended warranty for $179. What is their expected value for each warranty? This is the first one that I would say you might want to go and look at the, what do we call this? Your study guide key, or, your formula sheet, I guess. The expected value looks super, super confusing, but it's actually, I like the second formula. It's the value, basically, of option 1. You can even think about that as option 1, or they call it outcome 1, times by the probability, plus the value of opportunity 2, or outcome 2, times the probability. And then however many ways that this can be thought of. So when we go back up to this question, basically, how many things can happen? Well, we actually only have 2 outcomes. So either the AC unit fails, or it doesn't fail, right? So those are your 2 outcomes. What we call outcomes. And so what I want to do is figure out what happens money-wise, okay, if it fails. So let's talk about fails and not fails, which we can put a line over the top, means do not fail, okay? So value-wise, if it fails, and this is to Frigidaire, what happens? So if it fails, they may lose $2,000. Okay, if it doesn't fail, okay, then if they have a warranty, then they just made $179. Okay, so that's what we would think happens. However, even though it fails, if the consumer did put a warranty on it, which is what we're asking, is when they get a warranty, what kind of money will they be making or losing? They lose $2,000, but they actually still gained the $179, if that makes sense. So because they got that up front, and then they're going to have to spend $2,000. So that's the value if it fails, and if it doesn't fail, then they earned $179. And then we want to talk about what's the probability of it failing. So the probability of it failing is 3%. I'm going to write that as a decimal. And the probability, I'm kind of just creating a little chart here, but the probability that it doesn't fail is going to be 100% minus off the 3%. So in other words, 97% of the time, if 3% it fails, because it can only fail or not fail, 97% of the time it's not going to fall. fail. Okay, and what we're going to do is we're going to multiply those. So the expected value is going to be negative 2,000 plus the 179 times by 3% plus a gain of $179 if it doesn't fail, which has a probability of 97%. Okay, and I'll put the answer to this up in the key. How much should they expect to make or lose if they sell 10,000? What we're going to do is take our answer from A and we're going to multiply it by 10,000 because that's how much the answer to A is how much they're going to be making, again, on average. Expected value, law of big numbers for every 1 unit, and then multiply it by 10,000. Okay, moving along here. Question number 7. A test was given to a group of students. The grades and gender are summarized below. If one student is chosen at random from those who took the test, part 1, find the probability that the student was female or got a B. And so with an or statement, you want to think about all, one or the other. So the probability that they're female, just change it, we'll change it, yeah, is 37, right? So 37 females out of, a group of 61. So that's the probability that they're female, right? What's the probability that a student gets a B? Well, for that, I'm going to look down the B list or column, and there are 24 out of, again, your total 61. So if I had asked what's the probability of being female, you would say 37 out of 61. What's the probability of drawing of someone who got a B? You'd say 24 out of 61. This is similar to our question on the face cards, okay, where there's an overlap. So if there's an overlap, we have to subtract out the overlap. So we're going to add those two together, but subtract out the probability that they're female and have a B. So if we look at our female row and our B column, we see the overlap is 11. So I'm going to subtract out 11 of those students. Okay, so I'm going to get 37 plus 24 minus 11. Or in other words, I get 50 out of 61. Okay, which again, I would accept if a question like this, I would accept either a fraction or a decimal unless I've told you otherwise, although I like fractions. All right, what's the probability of male and C? If I'm asking for an and, I want to think about, this is where I only consider the overlap. Okay, so let me erase my colors here. What's the probability that I draw a student who is both male and got a C in the class? And so I'm going to look for the row of male and C, and that's it. That's my numerator. So I'm going to put 4 out of 61. So, and is only the overlap or includes everything, take off the overlap. Part 3, what's the probability of A given that the student is female? So we have to understand, first of all, how to read this. So what's the probability basically that they received an A? Given, that straight line means given that they were a female. I like to think about this straight line as basically a numerator and a denominator. And so the female is going to be, or the number of females, I like to think about it like that. The number of females is going to be my bottom denominator. So I'm going to go up and look for how many females there were. And so I see there were 37 looking along female. There were 37 total. And then I'm looking only at that row, and I'm looking for the number of A's. And so on that row, there are 14 students who got an A. So there are 14 out of the 37 female students who got an A. And then reduce, if possible, 37 and 14 don't have a common factor. So we would leave it as that fraction. Okay. Question 8. I love these questions, but they can be super tedious and can be a little bit confusing for a lot of students. So what we're doing here is we're creating a two-way table. This is actually Bayes' theorem, which is super, super useful. I always, if you were in my class, I would talk about COVID and whether we should have tested for COVID, given whether, false negatives and false positives, because it's fascinating, especially where we've just come out of a pandemic. And you can do Bayes' theorem using this table idea. So take a deep breath. We can do this. If a disease has an incidence rate of 0.8%, okay, when we have a table here, by the way, this number at the bottom corner is random. Okay. They gave you on the review, or I gave you that number to work from, but you could certainly choose 100, you could choose 10,000, you could choose 1,000,000, because we're going to just find the probabilities. And so the base number is not as important as using the numbers to find the probabilities. So if that number isn't given to you, you can pick whatever you want. Usually a bigger number is more helpful than a small number, because we're going to end up with decimals. And especially where we have a very small incident rate to begin with, we want to make sure that this is big. Okay, so they chose the number 10,000. Again, zeros are much easier to work with and ones. So that's why it was chosen, but it's kind of a random number to choose. Once I've chosen what that random total is going to be, if the incident rate is 0.8%, that means that we have 0.8% of the population randomly has this disease. And so to calculate a number for that, I'm going to take that number of 0.8, which is 0.008 when I write it as a decimal instead of a percent. And I'm going to multiply it by the total, that random number in the bottom right-hand corner. So we're going to take 0.008 and we're going to times it by 10,000. And that gives me 80. Okay. So 80 out of 10,000 people will likely have this disease that we're referring to. Let's jump to our next percent and see what to do with that. The diagnostic test used to detect the disease has a false negative. So let's think about what that means and where that number would go. False negative, obviously negative means I'm probably going to look for that middle column of negative. And false means that they would have the disease, but they were told that they were negative, right? So this is the area, the disease and positive, that's what we want. And then no disease and negative, that's what we want, right? A test to have. So a false negative would mean that it's negative, but you actually have the disease. So I'm going to put the 10% up there as a decimal. But what should I multiply that by? In this case, sort of similar to, I jumped back up to my grades question right above. The female, right? So the 14 out of 37, we're only going to look on the row where that's occurring. So I'm going to take 10% of the 80 because only 80 people have the disease. So 10% of them would get a false negative result. So I'm going to take 80% of 80, not the 10,000, which would be 8. So 8 people would be getting a false negative. Going on to the false positive of 7%. False positive, again, that's going to be in my positive column. False means that they don't have the disease, but they were told, or, by the test that they might. So we're going to put the 7% in positive, no disease, and I'm going to multiply that by that row. But wait, that row's total is not there. So to get it, I'm going to do all of these calculation ones. And let's choose, I'm going to do blue. If it's blue, that means that it's a calculation of just adding, subtracting. So to figure out this total in between, 80 plus whatever I have there needs to add up to 10,000. So it's going to be 9,920. So we have 7% of that row, which is 9,920. So I'm going to take 0.07 times by 9920. That's going to be 694.4. This is where, again, decimals are going to occur. That's okay. Please keep them until you get your end answer, and then you can round. The rest of these, I probably should have done that in green, but the rest of these can all be calculated by adding and subtracting. So I'm going to go to that blue color. If I add across, I should end up with 80. So that's going to be 72. If I add across, I should end up with 9,920. So I'm going to take 9,920 minus the 694.4 to get that middle number on my table, which is 9,225.6. Add down. So since I already have that 9,000 in my calculator, I'm going to add 8 to it. That's 9,233.6. Remember, those should add across to give you 10,000. So I'm just going to subtract the 10,000 and I get 766.4. So all these ones in blue, basically you just add and subtract on the rows to get them. Okay. Now comes the questions. Usually for a lot of students, the hardest part is filling out that table correctly. But now let's answer the questions. What's the probability of B? So that would be 766.4 over the 10,000. The probability of not B is 9,233.6 over 10,000. And again, at this point, you'd probably change those to a decimal and maybe even a percentage. And I'll leave that calculation to you and I'll put it on the key. Find the probability of A given B. Okay, so this is, again, I like to think about it as a fraction. I'm going to always start by finding the total of B. In this case, it would be 766.4. And then I would look on that row or column, because it's B, it's a column. On that column, how many of them are A? And in this case, that's 72. And then the probability of not A given B, again, B being your denominator, the total of B is 766.4, and our numerator is not A, or 694.4. Okay. And then again, like I said, change those to decimals or percentages. Okay. We got through that one. Let's move on. The rest of the sections, not generally as hard. Moving on to z-scores. We do give you the z-score formula. Z is your data point minus mu divided by the standard deviation, okay, or the mean is the mu. So you might want to write that at the top of your page. It's your data point minus mu divided by standard deviation. So we have to understand that standard deviation is the denominator, and mu is going to be your average. Okay? In this case, it's going to be 86. Once I know that, question number 11 is basically a plug and check. So if I want to find the z-score, I'm going to say z, that's what I'm trying to find, is equal to my data point, 112, right, beats per minute, minus, and now I look for the average, which was 86, and then I divide it by the standard deviation, which is 12.5. And then you do similarly for part B, except for it would not be 112 is your data point, it's 69, okay, minus 86 divided by 12.5. And of course, anytime you get a negative z-score, that's fine. It just means it's below average. And if it's positive, then it's above average. We can tell right here, the 69 is below the average resting heart rate. Question number 12 actually just works it backwards. So this time you're going to plug negative 1.05 on the left-hand side. You're finding the data point, and then again, we will give you the mean and we will give you the standard deviation. So the mean is 68.8 and divided by 3.1. I'm going to go ahead and show you how to solve this one if you need it. So this one's an algebra question at this point where I'm going to multiply both sides by 3.1 to get rid of, I'm going to do it in parentheses instead of the dots since I already have decimals. So 3.1 multiply both sides. So I get 3.1 times by 1.05. So that's going to be negative 3.255 equals my x minus 68.8. To get x alone, I'm going to add the 68.8. So adding that in my calculator. Let's see. Let's wrap this up. We've got our last question, question 13. That's an unlucky number to end on, but hopefully you guys are lucky on your tests and can remember everything that we have gone over. This question is about text per day. So suppose the amount of text sent by people in a given day, given that they have a cell phone, is normally distributed with a mean of 40 and a standard deviation of 12. So your mu is 40 and your standard deviation is 12. So find the z-score. So this is basically what we've done before. Z is going to be my data point 51 minus 40, and then I'm going to divide it by 12. Part B, should we consider this unusual? So I'm going to actually punch my number here to see what my z-score is. My z-score is 0.916 repeating. Okay. Should we consider it unusual? Okay, so unusual, we have to think about what does unusual mean. And so unusual when we talk about kind of a normal distribution. Then unusual, and there's some debate about this, but by most definitions is considered beyond 2 standard deviations. So more than 2 standard deviations, or further away than -2 standard deviations. So because I haven't even reached a 1 there, this is, if I'm texting 51 texts per day, I'm completely normal. Okay. What amount of text per day is exactly 3 standard deviations above the mean? So a standard deviation, remember, was 12. And so if I have 3 of those, that's 36. Okay, so 3 standard deviations, just multiply by 3. But above the mean means that we have to add the mean to it. So if I was texting 70 texts per day, then I would, 1, be considered unusual, and 2, be exactly 3 standard deviations above the mean. 2 standard deviations below the mean, if a standard deviation is 12, 2 of those is 24, but it's below the mean, so I'm going to take the mean minus 24. So if I'm only putting in 16 texts per day, I would be 2 standard deviations below the mean. This is, I'm going to write up there on C, that's unusual. We would typically call anything less than 16 unusual as well. Okay, so if I have more than 76, for sure I'm unusual, because I'm 3 standard deviations, not just 2, but 3. And if I'm less than 16, I'm unusual. Okay. And what's the probability that a random selected cell phone user generates between the 2 values you just found? This is where I'm going to make this super small so you can see both of them at the same time. You'd go to the normal distribution chart, and basically you want to, we found a data point like 16 texts is down here. That's 2 standard deviations away. And then 76 texts is up here. So to find the probability between standard deviations, you can just add them up using your table or your standard deviation kind of normal distribution chart. And so just add all of those percentages up. So at 13.5% plus 34 plus 34, which is 68%, right? Plus another 13.5% plus 2.35%. If you know the rule, you could have added 95% plus that. So I believe it's 97.35% of people would text between 16 and 76 texts per day. Anyway, that covers everything on the review. I'm going to stop here, and I will add to this video or add in a separate video any questions that you've got from the exercises. So hopefully you find this helpful, and good luck on your test.